Hello everyone. This is the video lecture for Math 1314. We're now doing section P.2. So exponents, essentially. So we're going to do exponents. So exponents are something like whenever you see x squared, it's that little 2 at the top. But, we're going to do that, but later, right now, what we're going to focus on is like numbers and stuff here in a few minutes. So you could do like 3 squared. 3 times 3 is 9. Because again, that means there's 2 of them. So x squared would be x times x, blah, 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 etc. So now you know what I'm talking about. But what we're really wanting to do are the properties of them. And how do you manipulate them? How do you simplify them? So product rule. What I'm going to do is I'm going to give you like what the formula is here. And then it says example. I'll just do something with like 2s and 3s or something like that. So you can see what's going on. So product rule is whenever you have some kind of base and you have a power m and you're multiplying it by another thing with the same base now to a power of n. So you mush your b's together into a single base and the power is now m plus n. So that's product rule. So if you're multiplying your bases, you're adding your powers. Again, you're multiplying your bases, you're adding your powers. And I would love to just write that down as a phrase. Maybe you should, because that's how I remember. It's one of those like ringing a bell kind of things, okay? You'll hear another one here in a second that makes a lot more ringing bells. So example real quick. So I got 2 cubed times 2 to the 4th. Again, I'm wanting to use numbers so it's not very scary. This is actually 2 to the 3 plus 4, 2 to the 7 power. Now, I want to like just prove that to you. I know that looks like 27. That's 2 to the 7 power. I want to prove that to you. So 2 power 3 times 2 power 4, and I got a number. But 2 power 7 is the exact same thing. So what we're doing is correct. I guess even an intermediate step, you could. You got to use parentheses in Desmos. There you go. So they're all equivalent. So there you go. It's kind of like a mini proof of what's going on there. So power rule. So this is b to the m, now all to the n power. Man, got a little bit weird there. And so what you can do is you can mush together your 2 exponents by multiplying them. So powers of powers multiply. Powers of powers multiply. That's the ring and bell kind of phrase. A lot of people have heard that one. And so it's like, oh yeah, I've heard that before. There you go. That's where it came from. So I got 2 cubed and then 2 to the 4th. And so I'm going to multiply them now. 2 and then 3 times 4 up there. 3 times 4 is 12. And so again, I want to just prove that all this is the same. I got 2 cubed. And I want all this stuff to the 4th power. And then I can just do the same thing by saying, hey, what about the 12? So there you go. Cool. All right, quotient rule. This is when you're dividing. So I got b to the m divided by b to the n. What you can do then is you subtract your powers. So when you're dividing, you're actually subtracting. 2 cubed divided by 2 to the 4th. Now I got 2 to the 3 minus 4. That's 2 to the negative 1. Now, that's a little bit different because what we're going to have is a negative exponent, which gives you a fraction. And see, it says like decimal? No, I want a fraction. And then again, proving it that they're the same. There you go. And we'll see that. We'll see negative exponents here in a few minutes where we have to kind of manipulate it a little bit. In fact, you got 2 to the negative 1. What they're actually going to want you to write it as is 1/2. And so you see how this is the simplified form. Desmos kind of gave that to you. We're going to have to do the same thing with letters. So you can't just say, oh, Desmos did it all for me. No, we have to kind of still know those properties. So I'll show you that as we keep going. Let's just keep rolling. Here's a nice little rule. Anything to the 0 power is always equal to 1. So 2 to the 0 is a 1. 100 to the 0 is equal to 1. Even negative 1,000 to the 0 is still equal to 1. But do note the parentheses is around that thing. So notice how I'm getting those all to be a 1. Okay, so there is a little trick here. If the minus sign is not included, then it will be a little different. And we will see that here in just a moment. So if you ever have a negative, I'm going to just rewrite that because it is way tiny. If you ever have a negative exponent in the end, what you can do is flip it as a fraction. So I'm just basically removing the minus sign and putting it down at the bottom as a fraction. So that's just a universal rule for simplifying. We'll be doing that a lot as well. That was why we had 2 to the negative 1. They did it like this. But really what's going on is that's 2 to the 1. See, this is negative 1, and now that's a positive 1 in the bottom. So I'm taking the minus sign away. Doesn't look very positive there, Chad. Close enough, close enough. But it just, you don't need a power 1. You just rewrite the original, so you're good. Okay, keep cruising. We got a ton of little examples, and that's fun. So let's start going through these. First off, Desmos. No, I'm playing, but I'm kind of not. Some of the numeric ones, we could just get them done exactly as you see them. And so if you're sitting there and you're like, oh man, I don't really know, or if you're on a test and you're like, man, I can't remember this quite right, or I want to double check myself or something, gosh man, please use Desmos. Just try, give it a little extra there, because all of our memories are not perfect, okay? Desmos is there. Now, you can't use Desmos on these guys. I get it. But if it's a number, you got Desmos, man. So let's do this by hand, of course, so that we can verify and learn so we get the X ones, right? So when we got variables. What we're having here is the whole thing is squared. And so squared means that there's 2 of them side by side multiplied. That's what 2 means, the little 2 up there, the square. Well, how many minus signs we got? 2, so they cancel, make a positive, and 4 times 4 is 16. Done. So not too bad. This one's a little different. So notice that it's saying this 4 is squared and not the minus sign. It's just this thing. And so what we have is 1 4, and we have another 4, and 4 times 4 is 16, but we never cancel that minus sign. And that's why it has a minus right there. Anything to the 0 power is always equal to 1. That was an easy one. But notice that this one has a little separately. See, the minus sign's on the outside. This is what the 0 power is applying to. I'm applying it to the 5. So I've got anything to the 0 power is a 1. Oh, wait, the minus sign stuck around. And again, you could always verify these things in Desmos. I guess I could show you right now, since it's up. We could say power 0 for that guy. But then if you rewrite this one perfectly, you can see it's now a negative. So again, we're going to use these for when we got these x's. And they do get pretty complicated. Obviously, you can see that gets complicated. So let's go through these together. So when I'm multiplying my bases, I need to add my powers. And so I'm going to have that same base, but I'm going to now add these 2 numbers together. 2 plus 9 is 11. And you're done. That's all you have to do. Now, again, I want to show you, Desmos will not do this. And that's okay. That's a good thing. So you type it in and say, go, and it doesn't go. That's why we have to learn these concepts beforehand for whenever we're having to simplify these things, okay? So multiplying the bases, add the powers, good to go. All right, this guy, powers of powers are actually multiplying. So I'm going to multiply those 2 numbers up there. And I got 4 times 3 is 12. Again, that's going to be a negative. So I really like this. I like this. Chad likes this. That's my name, Chad, by the way. But my math lab does not. And so what we're going to do is say, a negative exponent, put it in the bottom. And that's the more simplified version there. And that's okay. When you see that, it'll tell you, if you get it wrong on my math lab, it'll say, hey, you need to put that in the bottom. They have those little special pop-up boxes, I guess, if you read them at least. A lot of times they just say you're wrong. So yeah, I get you not reading them most of the time. Okay, so here I'm dividing, therefore I'm going to subtract. But notice that I'm subtracting with a negative, as in like 2 negatives should make a positive. And so when I'm adding these now, I get an 11. And that's the final answer there. We're done. All right, this 2, this square, it actually will distribute to both of these terms. It applies to both of them. Now, I got to just remind you, because you've been in math or not been in math for a while, if you had a plus sign between them like this, and you say, oh, distribute the square, no. Not going to work. That is not the same thing. When it says 2 right here, it means that there are 2 of them Oh, I'm sorry, that's 4. There's 2 of them, and you sort of have to foil and stuff, and that takes forever, and I'm not doing that right now. That's not the point, but I'm just saying that it's okay right now because I'm not having a plus sign or a minus sign between them. Instead, it's a multiply, which means I can apply that square to both of them. It's one of those little rules that you just got to remember as we go. So I'm going to apply it to both of them. That's 5 squared, and then y to the 4th all squared. Well, this one's easy. 5 times 5, 25. Again, that's 5 times 5, right? Squared. And so you can also use Desmos to verify, of course. But notice here we got powers of powers, and they multiply. So I got an 8. And that is it. We're done. There's nothing else to do there, which is kind of nice. All right, for the doozy. This one's a huge one, and that's okay. Notice this 3. Ignore it, at least for a minute. I want to do the inside of the parentheses first. There's a whole lot to do here on the inside first. So I actually really want to use a different color for a minute. Will it let me do different colors? Look at that. Okay, I want to group these in like terms in a way, okay? Back to the black. All right, cool. So I want to group them in like terms. So my numbers, my A's, and then my B's. So looking at just my numbers, and again, we could do this like pre-written, like rewritten out, or we could just do it. But you can already see what that result's going to be, right? It's a -2. So it's up to you how you want to do it. You can rewrite it so it's like a little bit more clean and easier to see, which is what I'm doing here now. There you go. Now, I have B's and 6s here, and I just want to say, like, Chad's font, this is me, I'm Chad, hello. My font that's a B, and this is a 6. Notice that my B is more like a music sign almost, like a little, I don't know, something. And then the 6 looks more 6-y. So, I have to amuse myself somehow. And so I've got a -5 out of these guys. Again, what I'm doing is subtracting them. And here I'm subtracting them, and I want to take a second to do it correctly because I got 6 minus a -6. 2 negatives are going to make a positive 12. Okay, I'm running out of room. Do I have more room? I'm going to do this. There we go. So I'm going to just put it all down here. Sorry. So I got a little bit of things going on here. This one was a fairly easy one. This one's a little bit weird, but not too bad in the end. Because they're all being multiplied, that cube applies to every single one of them, even the minus sign. How many minus signs will I have? 3. 2 of them cancel. It leaves 1 behind, so I will have a negative in the end. So it's like I'm applying to each one of these. Here, 2 cubed. Well, I don't know, Chad. What is 2 cubed? 2 cubed. Oh, yeah, that's right. So, I mean, it's fine to use a calculator. It's not a big deal. This guy here, powers of powers are going to multiply. And so what I actually have is -5 times 3, which we'll figure out here in a second. It's 15. And then here I've got 12 times 3. And again, powers of powers multiply. So, yeah, what I have here is a -15. And here I've got a 36. Yay! We did it! Sorry, I just love doing that. It's not right yet. It's really close. Notice that negative, and they're going to want that in the bottom because apparently that is more simplified. And so it actually should look like this in the end. That's what my math lab wants. Yay! That's not a very sure smile. I'm just having fun with you now. All right, and we're done with that section. There you go. So thank you very much. Have a great day.